Now we will start the session. Okay. So in this session we will discuss about different perspectives of LLMs and RAG, large language models and retrieval augmented generation with practical demonstration how to work with AI based chatbots and how to train our own data set, different free and open source libraries for working with large language models and generative AI. Along with that, we will discuss about different platforms which we can use for analysis of the logs, whatever data we are training, whether we are working on training part or we are working on fine tuning part. How to evaluate the metrics, how to plot, how to go for visualization part. For that, we will use TensorBoard, wandb, different other platforms available. MLflow is there, NGRock. So these are very prominent libraries which we can use for execution as well as analysis of large language models. How to go for different analytics part by which way we can check whether our output is accurate or not. So many libraries available nowadays. Langflow is available, llama, olama, AI whispering based libraries we will discuss, and along with that we will see how to work with vector databases, because at the back end of large language models we have to work with vector databases. In addition to these, we will see different opportunities, challenges, impact of AI chatbots in current dimensions nowadays, by which way these AI based chatbots working in association with large language models, how it is impacting the industry as well as job market. As far as AI based chatbots are concerned, large language models are concerned, first of all, we will discuss about the base difference between these two terms, LLMs and RAG. And after that, we will see different other perspectives, and then we will start demonstration part. I will show you how to train our own data, by which way we can use our own documents to create our own chatbot, whether it is desktop based chatbot or cloud based. So as far as large language model is concerned, it is working on the basis of the data, whatever is trained, until and unless it is retrained with new data, it will not work. Okay. So if we want to integrate intelligence, if we want to integrate real time intelligence with LLM, in that case we have to work with RAG, real time search. So what is LLM, and how it is different from RAG? LLM is knowledge from training, whatever data is trained. You might have seen when ChatGPT was launched, then in its official documentation it was told that it is having data up to a specific time, up to a specific month and year. After that it is not having the data. But nowadays that particular LLM of ChatGPT, it is integrated with RAG. So along with real time search, if we are integrating, if we are using large language model, in that case it becomes RAG. Okay, so this one, retrieval augmented generation, rather than working on historical data. As far as ChatGPT is concerned, it works on historical data or whatever data is trained till now when you are firing the query, when you are firing the prompt. Because in AI chatbots, you might have seen that there is a specific term that is known as prompt engineering. So in ChatGPT, in Meta AI, in case of Gemini, in Perplexity, Corapo, whenever we fire some particular prompt, whenever we enter some particular prompt, it gives output whatever is having in its own database. It means it is LLM based, large language model based. But if we want that chat gpt or Gemini should work along with real time data, historical data, as well as real time search, in that case it will become under RAG integration. It will be part of RAG, retrieval augmented generation. So historical data as well as real time searching. Nowadays you might have seen that whenever we search something on Perplexity or chat gpt, along with previous data or pre-trained data, it checks real time world wide web. It scan the information from real time world wide web real time data. So that is major difference between LLM and RAG. So this point we should be very much clear that these two terms are not same. Okay, if you are developing a particular robotic application AI chatbot and it is pre-trained, it is not available for real time searching. In that case it is only LLM. But if we want that along with LLM, it should be able to scan internet, it should be able to search the internet in real time for fresh information. Then there is integration of RAG. Okay, so now we will see, as far as LLM RAG semantics are concerned, what about the historical perspectives? What about its timeline? Because first of all, we should be able to understand, we should be clear about its pathway, about its historical pathway, from where this particular term started. And nowadays, in current scenario, we are having access to thousands of chatbots. But from which particular year this particular term started? Okay, so we will see this part. Up to this point, is it clear to all participants? Are you getting audio and screen properly? Kindly confirm in chat window so that we will be able to move ahead. And very soon we will start the demonstration part. We will see how to work with Python scripts, by which way we can work on some particular implementations, how to train our own data, how to work on vector databases. So retrieval augmented generation, as just now we have discussed, real-time data along with pre-trained data, that is RAG. Now historical aspects. As far as at the back end point of LLM is concerned, there is a semantic technology. Okay, semantics plus semantic web plus NLP. Everybody knows about it. Okay, natural language processing is available, semantics is available, but what about its historical aspects? When this particular term started, what about its origin? You might have studied that in 1950s, this particular term came to the existence. Computational linguistics, machine intelligence, or artificial intelligence. Very first test in artificial intelligence was Turing test in 50s. And after that, but that particular term laid the foundation of further improvements, further research in natural language processing. Okay, so in 1957, so you can say Chomsky grammar you might have studied. generative grammar. Generative grammar means we are able to generate new type of script, new type of sentences, we are able to generate new type of content. Then rule based. So initially Turing test for machine intelligence, to evaluate machine level intelligence. You might have seen that in case of Turing test there was a very prominent test whether a machine will be able to identify human being or not, semantics or content generated by human being or not. Okay, but before that also, okay, so this one is the main point. In 1960s, very first LLM was proposed by MIT researcher Eliza. This was the very first LLM. ChatGPT is not the first LLM. In 1960, it was the first that was developed by Joseph Weizenbaum by MIT researcher, and that is the base of all large language models. You might have seen that in 2021 around ChatGPT was released, but around 50-60 years back, very first chat application, very first chatbot was released, and it provided the foundation for further research fundings in this particular segment. Then in 80s, neural networks, statistical NLPs for text processing, word to vector. Then in 2017, transformers. In 2018, first true LLM for corporate as well as personal applications, GPT-1. Okay, so this is the timeline. So before studying any particular concept, before going through any particular paradigm, first of all, we should be clear about its timeline, from where it started. What was the base of that particular technology? Who is the first person that created first chatbot? And nowadays, transformers are being used. Nowadays, different GPTs, these are under development and these are deployed for real world applications. Okay, now after that, you can see that LSTM at which particular date and time, at which specific timeline, specific technologies. So these are the key technologies that provided the foundation of large language models. Okay, core NLP 2010, but very first platform in 1960. Okay, you can see transformer 2017, Google brain and word embeddings 2011, and current era 2019 to present, we are working on scaled models, scaling based models, GPT-3, GPT-4, Llama, Mistral, thousands of models available nowadays. If you want to scan these models, if you want to see where is list of all of these models, so I will show you that platform also. Okay, so initially BERT was launched, bi-directional encoder representation from transformers. It was product of Google. BERT model actually, when we were working on Google search engine, in that case at the back end BERT was used, but Google did not release it as a chatbot. Google released BERT as a search engine, as part of the search engine. Okay, so if you want to see different applications, different models, in that case you will be able to see on this platform. So Olama, this one is also free and open source library, free and open source platform where all large language models available. Even DeepSeek is also available. So you can see DeepSeek. Okay, so models.
Sir, you can also paste the links in the Google, this Meet,
Okay,
Google Meet link.
okay, sir. So dear participants, link of this I'm sharing in chat window. So you can see gamma 3. If you want to see source code of or parameters of DeepSeek, so you can see 1.5 billion parameters, 7 billion parameters, 671 parameters. So you can see it. Olama, olama.com, DeepSeek, and it is fully customizable. So on how many parameters we want to work with. Okay. So if I want to push it, if I want to train it, if I want to fine tune it, that can be done. So it's fine tuning we can work with, its analysis, its implementation we can work out. Okay. So you can see 7 billion parameters on which, so you can see that if I download this one, 671 billion parameters. So obviously uh, we should be having very good hard disk. More than 400 GB space is there in DeepSeek. If I want to download complete pre-trained model of DeepSeek, in same way, if I want to see Llama, Phi, Nomic, Mistral, so Gamma, so all of these you will be able to work with. Okay, so it is only for your knowledge, it is only for your reference, that where we can get access to this particular list of all models. Okay, olama.com. Now we will discuss about some more points. After that we will start the demonstration part. I will show you how to work on Python programs, but before working on any programming part, we should be clear about its timeline. So, as just now we have discussed, in 1960s ELIZA, after that LSTM, Core NLP, Google Brain, Transformer, and nowadays we are in 2020s. We are working on different variants of GPTs, GPT-1, GPT-2, GPT-3, and so on. Okay, but very first large language model, very first uh, platform that was available, it was ELIZA. Okay, from MIT Press, from MIT Lab. Okay, so these are different types of large language models: pre-trained models, fine-tuned models, and multimodal models. In as far as pre-trained models are concerned, huge quantity of data. So as just now I have shown you this one, these are pre-trained models. All of these are pre-trained. If I want to download all of these any of these models for my work, you might have seen nowadays the lots of corporates, lots of educational institutes, lots of government offices, they are deploying LLMs for their own work. Okay, for example, in your university, in your institute, you want to create your own LLM as well as RAG, and you want that whatever query you are specifying, automatically its documentation should be released, automatically its document should be provided. In that case, what we can do, we can take pre-trained model and it will be fine tuned. Okay, if I want to go for only question and answers, only questioning, answering, only problem solving part, in that case we go for pre-trained model. But if I want to train my own data, for example, in our university, in our institute, we are working on some accreditation part, NBA, NAC, and we want to generate those type of documents with LLM, with our own chatbot. In that case, what we will do, we will use pre-trained model along with our own document. So I will show you that demonstration also on one PDF file, how to put a PDF file and in a pre-trained model, by which way its data will be accessed. If I want to work with high dimensional data or heterogeneous data or multimodal data like images, videos, different types of animations, presentations, data, MATLAB, scripts, execution. In that case, we have to work with this particular part. Okay, so multimodal for multimedia based content. This one, combination of text. Okay, combination of text with other models like images, videos, so that high dimensional heterogeneous data can be processed. Okay, so it's up to your implementation, it's up to your research work or research objectives on which you want to work, whether only pre-trained model. If we want to develop an ERP, okay, that is able to generate answers corresponding to our questions, in that case we will use pre-trained model. If I want to use my own data set, then we will use fine tuned models. We will go for fine tuning. If I want to use multimedia content, I want to generate animations, we want to generate videos, we want to generate some particular high dimensional data, in that case we go for multimodal models. Okay, so these are some challenges, obviously, so many challenges available. So we will discuss about that part also. But along with LLM, we should be clear, if there is something known as LLM, then definitely there should be SLM, small language model. Okay, if we are discussing about large language model, then definitely there will be something that is known as small language model. So what is that small language model? It is also having long history back. So in 1980s, by IBM, it was started for prediction of next word in a sentence. Okay, so it is not a new term. However, from last 4 to 5 years, we are working on ChatGPT, Gemini, Bard, Perplexity. But these terms are very very popular, and these are used in industry long ago. Okay, so very first small language model (SLM) was started by IBM in 1980s for prediction of next word in the sentence. In deep learning, you might have worked on different implementations when we work on long short term memory (LSTM). So in LSTM, in um, that particular implementation of deep learning, what we do, we go for prediction of upcoming sentences, prediction of upcoming words. Okay, so that is also associated with language model, but that is a small language model. Okay, so if we are working on dictionary part, if we are having a pre-trained model with a dictionary, and we want to see, okay, which words are closer to that specific word, so that type of implementation will be small language model (SLM). Okay, so we can work on that part also. Now we will see, so these are some historical aspects, and by which pace it is having so much prominence. And nowadays, what about future and research aspects? So we will discuss about this part also later on. But first of all, I will start the demonstration part. I will discuss about some particular data, and after that I will start the demonstration and how to work on these particular data sets, how to train our own data sets. So you can see that from last 4 to 5 years, what is the pace of AI chatbots, what is the pace of robotic market size. Okay, and as far as the prominence of chat gpt, as far as the prominence of chat based applications are concerned, you can imagine it with this particular data. At one place, when Netflix took around 4 years, 3.5 years to achieve 1 million users, ChatGPT achieved 1 million users in only 5 days. Even Twitter also took 2 years to take 1 million users. So, with this particular data, you can see that what is the fame, what is prominence level, how many people are using it nowadays. Everybody, whether somebody is a school level student or college level student or research scholar or academician or practitioner, everybody is using chat gpt, everybody is using chat based applications. Okay, and with this particular data, with this specific implementation, you might have seen that lots of jobs are in threat. So we have to be equipped, we have to be very very alert nowadays. We have to learn this particular technology if we want to survive in current market. if we want to survive in current IT industry, in that case we should be having appropriate skills, we should be having updated skills related to large language models, how to create it, how to work on RAGs, because most of the white collar jobs will be out of the market in very few time. If you have gone through the news 2 to 3 days ago, companies, so many IT companies are firing thousands of employees every day. Okay, I will not name those companies because it is not ethical point. Okay, but if you will go through that particular part, that specific news reports, you will come to know that which corporate agencies, which top level IT industries are firing thousands of employees every day, because LLMs and RAGs, these are replacing human experts. So we have to be very equipped, we have to be alert in this particular scenario. So now we will see which are those technologies, which platforms are available, and at the back end of large language models and RAGs, which type of database is used. When we work with ChatGPT, when we work with Dale or Gemini, at the back end we are having large language model, along with that RAG, real time searching, and pre-trained model, and with prompt we are accessing the output with prompt engineering. So what is prompt engineering? By which way we are giving the inputs. Okay, so that particular prompt engineering we have to integrate in scripts. Our data should be trained in such a way that different types of prompts can be accessible, can be put with that particular backend database. For example, one question I am specifying, that particular question should be able to correlate with the backend database. Okay, so now we will see which platforms we will be able to use, which technologies are available. Langflow, vector databases. At the backend, which scripts are available? LangChain for creation of models, for creation of agents, agent-based programming, for working with chaining. Chaining means whatever question we are asking in Chat GPT, you might have seen that whenever we put some particular question, in that case we can specify the follow-up response. Okay, follow-up response also. So along with Olama, we can work with LangChain for agent-based programming, Llama Index for creation of the prompt-based LLM and RAG, Llama Index. Okay, this one. So these applications we will discuss in this session. So you can see, and these are available in free distribution for researchers. AI knowledge assistants, if you want to create your own knowledge assistant, then how to use Llama Index, how to use Olama, how to use Langflow. Okay, so simply you will be able to use this one, low code programming platform for AI. Its APIs are available. Okay, API key we will be able to generate, and then we can work with our models. If I want to create my own RAG, I want to create my own LLM. Okay, with drag and drop as well as with Python script. So in both ways, these platforms are available. This one, agent based programming, Langflow, Llama Index, Olama. Now we will see how to work on these platforms. Now I'm starting the demonstration part, I'm starting the programming part, how to create an RAG application using LLMs at the back end and without paid API. Major part is that whatever demonstrations I will show you, these demonstrations, these scripts will be without using any paid APIs. No need to use any OpenAI API. Okay, generally when we work on such implementations, we have to buy the subscription of keys. Okay, OpenAI keys. But without OpenAI keys, how to work? With FAISS library, if I want to create my own chatbot, I want to create my own RAG application, I have two options. One way is that I will be able to uh, purchase OpenAI keys, and with few commands, with few instructions, I will be able to put my data, and then we have to work with specific tokens. Obviously, when we purchase some keys from OpenAI's, when we purchase some subscription from OpenAI, then some particular tokens are given. Okay, limited tokens, and it is linked with our credit card or debit card. But I don't want to use any paid API. I want to work with very simple RAG application without any paid API. So you can see no paid APIs, and everything will run locally in your local laptop or in your Google Colab. For that, we will use FAISS library, FAISS platform that is integrated with vector databases. First of all, we should be clear about vector databases. What is vector database? When we work with large language models, whatever data we train in LLM, in that particular AI model, it is stored in format of tokens. It is stored in format of numbers. Each and everything is stored in form of numbers, whether you are storing images, or you are storing documents, PDF files, or text. Even if you are storing the sentence, that particular sentence will be stored at the back end in form of numbers. Once it is stored in backend, by which way it will be accessed, and by which way we will be able to fire the query. For example, I am asking what is AI. This is one question. What is AI? In another way, I am asking same question. What do you know about AI? Whether these two terms are same or not. Whether these two sentences are same or not. How are you or H are you? Whether, so by which way this particular similarity will be identified? So for that we will use this particular platform. With this we will use this particular library, FAISS, Facebook AI similarity search. Search for embeddings of multimedia documents that are similar to each other. Embeddings. What is this term embedding? Embedding means whatever content we are storing in LLM, in backend vector database. Actually, it is associated with a number, and that is related to embeddings. Okay, so this one, efficient similarity search, we will be able to install it. So simply if I want to install it, with pip install FAISS, we will be able to install it. So you can see that this one I will show you in Colab notebook also. Okay, so this one, for for use for working with language model, we will use T5, text to text transformer model. Okay, we will use a language model, large language model or small language model. It is an online session, so I will take a language model that can be used very fast. Otherwise, if I will take DeepSeek, it is having 400 GB data. Okay, 400 GB weights. So obviously in Google Colab, 400 GB or even 7 GB data can't be taken. So for demonstration, we will take T5, text to text transformer. This is a pre-trained model, and in this pre-trained model I will use my own sentences, I will give my own sentences, I will train my own statements, I will train my own documents, and then using FAISS, using Facebook AI similarity search, we will go for prompt engineering. We will go for firing the questions and getting appropriate output. Okay, so what is use of FAISS? Whatever document we are storing, FAISS will go for similarity searching, vector similarity searching. Okay, whether you are using images, videos, or linguistic content. Okay, so for that you can see that this one is the code. I will show you in its in demonstration also in that particular in Google Colab also. Now I am opening Google Colab so that I can show you, and it is completely free and open source. FAISS. This is one platform, and in alternate to that you can use any other also. Okay, so this one I'm opening Google Colab, and here I will explain it. Okay, so first of all I'm showing you its complete. So for example, these are my sentences. Okay, I want to create this particular model with my own data. These are my own sentences. Okay, this is pre-trained model, this is low existing model. For example, I want to use here DeepSeek, I want to use here Llama, or some particular model of the Chat GPT. Okay, inside Chat GPT I want to train my own data. These are my statements. I can put my PDF also. Okay, so I will show you that part also, but before using PDF, I'm showing you very simple implementations so that you will be able to use it. So you can see that pip install. First of all we will install FAISS CPU, because we are using CPU. If you want to use GPU, so accordingly you will be able to install that package. Okay, so you can see that FAISS GPU. If you are having CUDA, okay, so you can see GPU for graphic processing unit. If you want to work with CPU, in that case you can work with CPU variant. Okay, this one. Okay, transformers. We are using transformers because whenever we work with large language models, RAG applications, we have to integrate this library sentence transformers, so that we will be able to access, we will be able to process these sentences, we will be able to analyze these statements. Okay, so load models, which model I want to load. So you can see that mini LM, this particular language model we are loading. This is RAG, retrieval augmented generation. Okay, first of all, so where RAG exists in this particular implementation? This is retrieval. Augmented, where is augmentation? This one augmentation, this one is augmented. I want to use my own data. For example, these four sentences: Eiffel Tower is located in Paris. This one, this is second statement, this is third statement, this is fourth statement. These four documents, these four sentences I want to train. Okay, now in this particular model I want to embed this particular statement. So doc embeddings. So obviously, so retriever dot encode documents, whatever documents we are using, these are the documents we want to encode. Encode means it will be converted to numeric format, it will be converted to numbers. Without this encoding, without this embedding, RAG or LLM implementation will not work. because for example I am asking, I want to ask in query where is Eiffel Tower, or which particular point is located in Paris, or where is Paris. Okay, so I want to create so many sentences, I want to create n number of sentences or n number of questions corresponding to this particular statement. I want to create n number of questions corresponding to this statement. So for that, first of all I will have to encode it. It should be converted to embeddings. Retriever dot encode what I want to encode. I want to encode my documents. No need to encode this one, no need to go for encoding of this one, it is already encoded. So you can see it is fast embedding model. If I want to use DeepSeek, so no need to encode it, it is already encoded. Okay, it is already embedded. In that I want to put encoding or embedding of my documents. Is this clear to all of you? Are you getting this point what we are discussing? In chat kindly confirm, are you getting? Chat only. Okay, whatever pre-trained model we are using, inside that we want to use our own data. Now further we will see this one, create FAISS index. So this one embedding size, index flat L2. So these are different index distances L2, L1, L2. What is this? FAISS index means using which metric, using which formula we want to see distance between our question and backend database. For example, I am asking what is Python. Okay, in this, so what is Python? It will be converted to numbers, and using indexing, it will check that Python, that description of Python is written in this statement, and by which way answer should be given, by which way response should be given from this particular statement. Okay, so doc embedding, add embeddings to FAISS. Now creating a RAG query. RAG query. So whatever question we will give, so I will show you whatever question we are giving. For example, our question is where is the Eiffel Tower? Okay, this one. This one is our question. This is query. So where this query will go? This query will move to this one. Okay, to this particular module. How many tokens? How many tokens we want to generate? So you can see max length 50, max length 500. So you can see that output IDs in chat GPT, in different AI chatbots you might have seen, uh, users are required to pay, they are required to subscribe depending upon the number of tokens. So how many number of tokens we want to use? So obviously more tokens, so more overhead to the algorithm, and obviously more charges we have to pay. Okay, so for example this one I am executing. So I am asking some question, and it is running now. FAISS NVIDIA. Okay, so whatever question we have given here in this code, it will be, and it will access the answers from these whatever we have given. Okay, in our own document. So it is downloading, and now you can see that. So after installation of required packages, we will be able to search. So you can see that it is running now, and once it is done, then finally we will be able to see the output. Okay, so these documents can be in any numbers. Okay, any number of documents, any number of statements we will be able to put, we will be able to specify. So you can see that now it is running, and
So you are not audible, sir. Little, no.
is it audible to all of you? Is it audible to all
With-
other participants? Kindly confirm. Is it is it audible to all participants? Okay.
yeah, yeah. Now it's okay.
Mhm.
Audible, sir.
Okay, sir. So you can see FAISS CPU is installed. So this is FAISS, free and open source platform for similarity searching. So now you can see that it is downloading that transformer, and now embeddings. So you can see this is the question, where is Eiffel Tower, and this is the context. So from four documents, so this is the output. You can see that from four documents, from four statements which we have given, it has given this particular answer. Okay, this particular statement it has identified using similarity searching. Okay, any other question you will be able to ask. So what we are doing, we are updating the existing model. We are adding our own documents. Okay, so this is the code. So I will share this code to all of you at end of the session, and along with its output. Now, so this one is the screenshot. Which question we have put, for example. So any other question you will be able to ask. Okay, so simply you can copy this code, you can put any number of documents. So there is one query: is it possible to search text in those documents which is having text? Yes, definitely, we can work on that. So using multimodal modules, I will share some references to work on these implementations. Okay, I will share you some references at end of this session, so that you will be able to work on these. Okay, so this is very first implementation. So whatever documents we have trained in existing pre-trained model, in existing T5 model, and we are firing the questions. Okay, any other question we will be able to put. Now in same way, for example, fine tuning, or we want to see, for example, this one. Okay, this one. So I am opening this in notepad. Okay, this one is the notepad, and here we will see we want to use FAISS for prediction of next word. Okay, or for finding similar sentences, this one. Okay, so this is our library: transformers, FAISS, sentence transformers, and loading of existing model, all mini LLM we are taking. Now sample data set, sample files, these are sample statements, and in same way we will use it. So I will change some questions also. For example, this one is our code. Okay, I so for example, this one is our question, and I want to ask about machine learning. Okay, this is my question: what is machine learning? Same code. Okay, same script, and I want to see to which particular statement it is more close. Okay, so this is pre-trained model. In this particular pre-trained model, I want to use my own document, I want to use my own statements. Okay, so initial demonstrations I'm showing you on statements, on sentences. uh, After that I will show you on PDF documents, how to put your PDF documents in vector databases. But just to make you comfortable, I'm showing you small implementations initially, and after that we will go for some other applications. So you can see this is L2, Euclidean distance. So by which way it is identifying? For example, this is my question: what is machine learning? So this question will be given a number. For example, any number will be associated. Each and every other statement is having a number. So using Euclidean distance, using Manhattan distance, using city distance, using cosine distance, so many metrics available. So using those metrics we will be able to see which particular l- sentence is closer. Okay, so I'm specifying here this hash because it is already installed, no need to reinstall it. So you can see that I have asked what is machine learning. So machine learning is a subset of AI. So most similar sentence. So you can see, now I want to ask where is moon. Okay, so which is most similar sentence? So the moon orbits around the earth. Okay, Great Wall of China. What about China? What about China Wall? I'm not asking about Wall of China. I'm not asking about. Uh, I'm not writing exactly about some particular statement. I'm asking about, okay, this one. What about China Wall? This one. Enter. Now, which is most similar sentence? This. So, what about only wall? So you can see that this. So using vector embeddings. So what is done? This particular statement is given a number. Okay, all of these statements are given number using Euclidean distance, using L2 Euclidean distance. If I put L3, if I put L4, different methods available. For example, so you can scan it. So you can see that this one, it's in its official documentation. What is L3? What is L4? Okay, so different other functions I want to try, different other methods we want to try. So we can see it's in its complete documentation. So this one, structure list, L2, and you can see that this one, index flat L2, index HNS, index. So as there is one query in chat, if you want to search for some text in image, so in that case we have to see for images which particular distance metric will be implemented, whether cosine distance or Euclidean or Manhattan or any other. Okay, so you can work on that. So these scripts I am saving separately on desktop, and at end of this session I will share these scripts to all of you. Okay. Now some more implementations. Fine tuning of text generation. Fine tuning. Okay. Fine tuning along with its analysis part. Fine tuning of RAG, and by which way we can go for its analytics. So these are the steps. Install dependencies. So what is our motive? First of all, we are taking a GPT model, Distill GPT-2. In Distill GPT-2 we will use our own custom data set, and then we will see the refined output. Okay, so you can see previously what we have done. Previously we have taken all mini LM. Okay, in this also we have taken mini LM. Now we are taking Distill GPT. So in olama.com, you can search for Distill GPT, okay, or Distill. So you can see, or GPT model. So many GPT models available. Any of these you can take, and we will be able to fine tune it. Okay, so this is our motive. This is our next task: fine tuning of GPT like model using transformers. Okay, so what we are doing. So along with that, we will see how to work with wandb, how to work with analytics part. Okay, so this one is a script. How many of you are aware with wandb? W A and B. If we want to analyze, if we want to evaluate our output, we can use a third party library. We can use a platform that is known as W A and B. Okay, for analytics part. This one. When we work with large language models, when we work with RAG models, we have to generate this type of output within whatever code I am running. For example, one code I am running here, I want to generate its loss, its epochs, accuracy. So what we do for that, we use this library w a and b dot ai. Either you can use, so w a and b stands for weights and biases. Okay, weights and biases. So whatever code we have run, we have executed, by which way it is transforming. Okay, so what is the epoch? This one. What about the accuracy level? So if I want to save any of these, so you can see this one. So till, so in 89.62% accuracy achieved in how many epochs, so that we can go for it. Okay, so this one. So in, so generally what we do, whatever output we execute in Google Colab, we show epochs, accuracy and loss within Google Colab. I want to store it separately. To store my accuracy, loss, epochs on separate platform, in that case we use this W A and B. Okay, this one. So uh, some implementations we will see without W A and B, and some implementations we will see along with that. Okay, so this one, if I want to disable W A and B, so you can see I'm writing here wand b underscore disabled is equal to true. Which model I want to train, I want to take distill GPT-2. Auto tokenizer pre-trained we have taken. Which new data, custom data, this is my fine tuned, this is my data for fine tuning. This one is the data for whatever I want to train. Okay, in text format. Now embeddings, in same way we are going for its embeddings. Okay, trainer dot train, and then we will see what is the output. Okay, so which particular question, so for example this particular code I am taking here, this one, and this script, and after that, so I'm taking this script and I will explain. Okay, so this, so first of all we are installing the transformers, then you can see W and B disabled. Otherwise, if we will not disable it, in that case what will happen, wand b error we will get. Okay, by default it is enabled. Now which model I want to take, pre-trained model distill GPT-2. You can take DeepSeek, but obviously if we will take DeepSeek, then our memory and GPU, so many things should be ready. Okay, auto tokenizer, then custom data set. This one is the custom data set. Okay, now this code I am using for prediction of the upcoming sentences. For example, I want to write, I want to search for pizza
राहुल
dot dot dot,
नमस्कार, बल्ला साहब पे तो नहीं अंदर,
or python
बल्ला
dot
साहब
dot
तो
dot.
नहीं अंदर।
Okay, In that
कोई भी
case,
नहीं है।
we will
हाँ,
use. So
कोई भी नहीं
prediction
है,
of
आज कोई भी
upcoming
नहीं है।
sentences.
मैं मिलना था तो सब इधर भी नहीं, पता नहीं वहाँ होंगे, मैं समझ रहा था। नहीं है ना? थैंक यू।
Dear participants, kindly mute your mic. Some mics are on. So we are training, and once it is trained, so on same notebook, I am using this one. This one is the script. Okay. So in how many epochs? So this one is my custom data set, and what I want to predict. For example, input text dogs are, or I want to predict for dogs dot dot dot. So from which particular statement, from which specific data, it will it will be giving me output. So this one trained text wandb is disabled. Okay, wandb disabled true. Distill GPT-2, and in how many epochs I want to work. So you can see this is my question. Dogs are, and we are working on that particular prediction, that specific sentence matching, and you can see that this one stop train this step training and loss. It will be logged in this one. Okay, it will be logged separately. It will be stored separately here. So you can see generated text, and this particular output is taken from this one. Okay, so for example, I want to search for something else. I want to search for some other part, like I want to search for dot dot dot. Okay, so in chat gpt we can use this particular statement also, three dots or simply question mark, and you can see that it is running. And step training loss, it will be recorded separately. It will be recorded separately in wand b. Okay, so what we have to do, we have to take its apis, and with those apis we have to uh, work with. So you can see that this one. Okay, so any question you will be able to put, any type of query you will be able to put, and this one is the output. Okay, so this is question, input text, and from which data it has accessed the output, from this particular data, from this specific data in text format. Okay, in same way, text sentiment prediction, you can go for it. Okay, if you want to go for text sentiment prediction, band b, this description I have given here, by which way you have to work with it. Okay, now we will see by which way we can see this particular output on screen. Okay, either you can use wandb or you will be able to use tensorflow. Actually we are having limited access of wandb platform, because in free tier limited tokens are given. If I want to use free and open source platform for LLM visualization, in that case we use tensorboard. So this is best option for logging of the outputs. If I want to log, if I want to record all output from uh, a particular scenario, in that case we can use tensorboard. So this one is, it is part of tensorflow. Now we will see some implementations related to tensorboard. Whatever output we are running, how to take its output, how to take its visualization in very effective format. Okay, this one. What is TensorBoard? Whatever LLM and RAG we are fine tuning. For example, this is your research work. In research work, I want to, obviously we have to achieve 99% accuracy, 97% accuracy. But which platform we will use? Either we can use wandb or we can use TensorBoard. Whatever code we are executing, along with that specific code, we can integrate TensorBoard. So this one is the code. For example, this one is the script. Okay, this one is script for training our data set, and once it is done, after that I want to see its its accuracy in TensorBoard. So whatever model we have trained previously, so this one TensorBoard, I am running TensorBoard within Google Colab. So you can see that this one launching TensorBoard. So previous execution, whatever we have done, it is linked with this free and open source library so that we can check its output. So you can see that this one within Google Colab, within free variant of Google Colab, we are running. So this one, if I want to save it, so we can save. Okay, simply right click, save image as, enable range selection. This one, okay, all values. This, okay. What about the loss factor? This one is the output. So whatever output we are getting, whatever execution we are performing on machine learning, deep learning, or RAG, we are integrating it with TensorBoard. Okay, no need to install it separately. It will be uh, enabled automatically once this particular command is executed. Load extension TensorBoard and log directory. Is this visible to all of you? Is this visible and clear to all of you? Up to this point, by which way we can work on different free and open source extensions. These are some additional extensions that we can use. Okay, now I want to work with this one, FAISS plus TensorBoard. Okay, FAISS plus TensorBoard, one mini language model we have integrated. We want to fire a particular query, and along with that particular query, we want to use its plots, we want to generate its charts. So you can see that first of all we have installed FAISS CPU sentence transformers. Then this particular model we have taken our data set. Now up to now code will be same. Now after that what we will do, we want to integrate TensorBoard, we want to see its logs. Okay, so for that I'm using this particular code, this one. So all of these scripts I will share to all of you so that you will be able to work after this session. This one code, and I will remove that installation part because it is already installed. Okay, so multiple questions we have put. Okay, so you can see that with the distance matrix. So what is distance? So you can see this one, retrieved answer, this one, Second query, what is distance? So this, and with TensorBoard we are able to view outputs. We are able to record the loss. Okay, loss, accuracy. So how much accuracy we are getting? Okay. So if I want to save it, so save image as we can perform. Okay. Okay. So if you want to work with some particular small chatbot, for example, a small chatbot you want to use. Okay. Now we will see one implementation related to a text file. Up to now, whatever we have seen, uh, means we have integrated some sentences. Now I want to train my own text file. I want to train my own data. Okay. So in this code, you can see that this doc3.txt, in this file, my content is available. This file may be PDF file on chatbot without pre-trained. We are not using any pre-trained model. Up to now we have seen one pre-trained model we have taken, and in that pre-trained model we have put our own data. Now what we are doing, we are creating RAG application for our own data file. Okay, for that you can see from google.colab import files, this doc3.txt file I will upload. Whatever file I will upload, first of all I will show you what is inside that particular file, which particular text is written. And once that particular text is accessed with FAISS, Euclidean distance, whatever question I am asking, for example, uh, so first of all I'm placing this code, and after that I will show you how to use it, by which way we can train our own data. I want to train my own text file or PDF file. Okay, so I think somebody's there is one message regarding mobile phone. Actually, I am not using any mobile phone. I am not having any. It is not vibrating in my system. I think somebody else system. It is this particular thing is going on. Okay, there is no noise in my surroundings. So I request other participants to mute your mic, because in my room, in my setup, there is nothing related to noise or vibration. Is this clear? So I request other participants to kindly see whether your mic is off and there is no vibration. So you can see that this one is the code. And first, now I am showing you the file. Okay, one file I am showing you. This is the file. Is this notepad visible to all of you? Is this notepad file visible to all participants? Kindly confirm. Now you can see in this notepad file, doc3.txt, something written about WLAN. It is written about wireless networks. Okay, I want to train this file in RAG. In my own, I want to create my own language model without fine tuning. Main point is that I don't want to fine tune. I want to create my own model, and that is trained on this data, which is available in doc3.txt file. So what I will do, this is my code. Using FAISS library, I will perform same thing. Okay, so you can see that this one, it is already installed. So I will so I have placed comment. So import FAISS, and load file. So import, so this doc3.txt file, this is the same file which I have just shown you. Okay, this is the this one is the text file on which I want to train a model, and I will ask some questions. So I'm again showing you this file. This is doc3 file. Now if I ask, so in this particular file, there is the content related to wireless network, but I will ask some question in between the document. For example, I am asking what is WLAN. So rather than giving answer from this paragraph, it will give me very accurate answer. It will give me very accurate response what is WLAN. Okay, if I ask what is radio wave, so it will provide me output from this paragraph only, because each and every sentence will be trained, each and every sentence will be embedded separately. So you can see that doc3, and now I will ask what is WLAN. First of all, I am executing it, and in TensorBoard we will see the logs also. So you can see load underscore ext TensorBoard, so that we will be able to see the output. Now we have executed it. I will upload doc3.txt file so that my LLM will be available. So we are executing it, and once it is done, after that, so it will ask me for the file, it will ask me for the document to be trained. Okay, other participants kindly mute your mic. I request other participants kindly mute your mic. So you can see it is asking me to upload the file. Now I am uploading the doc3.txt file. I am uploading doc3.txt file. Now you can see that I have asked the question what is WLAN, and this is the output. Okay, so this is the, and this one is the text file. So it is not giving me output from first statement. It is not giving me output from uh, haphazardly any particular content. You can see that first sentence is written about wireless network. Okay, after that definition of wireless network, WLAN is given here. So it has given me this output, this one. So but I have asked what is WLAN, it has given me this output, the most common type of network, this one. So rather than so after scanning the complete document, it is giving me very accurate response, and along with that, in TensorBoard, I will be able to see its accuracy. This one is the accuracy plot, loss plot. You can see this one, loss. If I want to ask some other question, okay, for example, I want to ask about what is I want to ask about this particular part. Okay, from that particular document which I have trained, what is wireless network. Now whether it will give me first statement or any other. So from a pre-trained model, so that I have already uploaded, so I will cancel, and now you can see that it is giving me the answer. So which question I have asked? I have asked the question what is wireless network, and this is the description. And in TensorBoard we are able to view the output, we are able to view the logs, accuracy plot, and this one, loss plot. Is this visible to all of you? Are you getting this point? Is it clear to all participants? Generate, training a document, and after that getting its responses. Is this clear to all? Kindly confirm. So one document we have trained, and after that we have accessed, we have put some questions, and then we are able to get the responses. Is this clear to all? Kindly confirm so that we will be able to move ahead. Okay. Now, dear participants, we will see one more demonstration that is very important, that is very useful for all of you, that is related to another very popular platform under free and open source distribution, that is Pinecone vector database. We will see one demonstration of Pinecone. Now I will show you one demo of training a PDF document. I want to train a PDF document in Pinecone. Okay, so for researchers it is freely available. I want to create my own RAG application. I want to train my LLM. For that, what we do, we can use Pinecone or we can use Milvus. Okay, Milvus vector database. Okay, pinecone.io, milvus.io, any of these you will be able to work with. Both of these are vector databases. Okay, high performance vector database. If you want to train your PDF documents, if you want to train your images, if you want to train videos, its cloud is also available. Zilliz Cloud. Okay, generative AI app, image search. So as you were asking about how to search for content in image, you can go for Milvus, generative AI app creation. Okay, RAG, multimodal support, hybrid search. Okay, so you will be able to work with it. Now one demonstration I will show related to Pinecone. Okay, so first of all we will create account, and after creating account, after signing up, we will log on to our Pinecone account. This is Pinecone. With your Google account, you will be able to log on. Okay. You will be able to log on, and you can see that with my account, I am logging in. And once it is done, you can see that this is Pinecone. Okay. Some particular indexes we have to create. So indexes means we want to store our own data. Okay, so first of all so either we can delete it. So I am deleting the previously created indexes. I want to work from scratch. So you can see this one, Pinecone. I want to use this database. Simply with pip install Pinecone, we will be able to work with it. In your anaconda prompt, simply you will execute this pip install Pinecone, and API keys. We have to take its keys. So create API key. API key means whatever documents we are training, whatever LLM we want to train. Okay, so that particular data will be available on Pinecone cloud. Its vector embeddings will be available on Pinecone. So you can download it also, but I am showing you its cloud variant. Okay, so its API key will be created, and once its API keys are created, after that you can either go for fine tuning of model. So load from dataset. For example, I want to take a pre-built dataset. Okay, so you can see embedding models. I want to take GPT-3, Distill 3, or any other. I want to take a specific data set related to particular domain. So in which language I want to work? Python, Java, Node.js, or any other. Okay, Go language, Python. Now this code already I'm having. So this one. So you can see that this one. This is the script. I want to train my own document. Which is the document? Which document I want to train? So first of all, I will show you one PDF file. This is doc.pdf file. This one, doc.pdf file. So it is only for demonstration. So one paragraph I have written in this PDF, I will train it. So I will train this document, and after that I will ask what is inside this document, or what this document is all about, like that, or any other question I will put. Okay, I can ask, okay, what is GPT-4o? uh, what about Azure OpenAI? So obviously for that I will have to train this PDF file. Okay, so what I'm doing, first of all, I'm creating one index. Okay, this one index name, this one is the code of Pinecone. From Pinecone API key I have given index name, create index, and now you can see I'm working on my system. So one Pine Connect. Okay, one Pine Connect, and index name, any specific index you will be able to see indexes. This is our index, and so Pine Connect, as soon as it will be executed, one index will be created at the backend. So this is the script. In this script I have created the index gk1. Okay, now I will see whether this index is created or not. I will click on index, refresh, and you can see that this index is created. Now I want to upload one file. I want to train my data, this one. Here what I'm doing, I'm uploading this particular doc.pdf file. Okay, so I'm showing you this one file path. I want to create one assistant. I want to create one AI assistant from this doc.pdf file. This is same PDF file which I have just shown you. This is the PDF file. I want to train it, this doc.pdf file. Okay, so this one, I want to train this file. So Pine assistant status. Now this file will be trained, and once it is trained, after that we will be able to put some queries. So first of all, it is training, it is storing that particular data in backend Pinecone database. Okay, now it is trained, and after that we want to see. So in this Pinecone assistant, listing of files, assistant dot list files. I want to list all files. So these are the, this one is the file. Okay, just now I have uploaded, so you can see that at which date and time it is uploaded. Okay, this one is metadata. Now this one, for, okay, describe, and we want to ask some question. So first of all, I will show you type 5. So this one is the code. I want to ask the question. Okay, what is, what this document all about? what this document is about. I want to ask this question. So Python, and now we are asking from this particular uh, chatbot, command based chatbot, what this document is all about. Okay, what is written in this document. So it will not give the complete output as it is, it will give in its own language. So it is accessing that output. Okay, so it is checking the embeddings. After checking the associations, it will give that particular response what this document is all about. Okay, and at backend we are having Pinecone. So very soon we will see the output. So you can see that this one is the output, and where is the output? So you can see this document discusses infrastructure operations, this one.